Now I'd like to welcome Gene Stevens, who is the head of Global Product Innovation at Verizon Business Group, and he's got a great presentation for you. Welcome, Gene.
Thank you, everybody, and thank you to the WSTA team. Thanks for inviting us. Thanks for having me, and thanks to those who are joining. This is a very well-run event so far. I'm really impressed with the organization around this, so thank you for all the hard work that goes into this. These are unusual times for us all. So I want to talk to you a little bit today about the intersection of connectivity and security. I've got about 15 minutes in which to talk with you, and so I'm going to be really mindful of the time so we can present and then have some Q&A. So I want this to be kind of conversational, even though Q&A is towards the end. And because we only have a little bit of time, I'm going to talk about some really high-level ideas that are meant to spur that conversation. We have a virtual booth and would invite you to visit that afterwards to learn more. So toward that end, what I want to do is talk a little bit about what I mean on the future of, I'm hitting next slide. There we go. Okay, so my role at Verizon is around leading the innovation effort for our products and offerings for all of Verizon Business Group. Previously, I was the co-founder and chief technology officer of a startup called ProtectWise. We were a network security startup. Security is my background. Spent a lot of time in that field. I'm really passionate about that. I'm really passionate about the network and seeing the intersection between networks and security and the future of business and the future of connectivity were a big draw when it came time to look at exiting with the company, and Verizon acquired it last year. I was in the security services division for a year, and now I have this new role leading innovation. So what I want to do is walk you through what's on this slide a little bit. This basic innovation thesis on the future of connectivity and the future of networks. And it basically goes along the line of the digital hub is moving to the network. That is a thesis. It's meant to be tested in the world. It's meant to potentially be falsified. And so I want to enter that with a little bit of humility, but I mean digital hub in a very non-controversial sense, the same way in which Steve Jobs would have used it to describe Apple's roadmap. He was very famous for using this as a phrase. And you could see, and then that kind of roadmap around the digital hub for people and technology as moving from the personal computer, where we would have office docs, web surfing, email, that kind of basic activity. You remember those days. Then we moved to the iPhone or the smartphone, where it was about cameras and movies and music and app stores and gaming and ebooks and that kind of stuff. And then it moved to the cloud. Right. And when Jobs would talk about this for Apple, he would identify these major milestones of movement and evolution inside of the market. Obviously, he passed away before they could execute on the cloud, but it stands to reason that our current circumstance is very much dominated by streaming content, mass collaboration, cloud-based gaming, a world and ecosystem full of APIs, and the earliest forms of artificial intelligence with machine learning and other kinds of supporting technologies. And now, and this is a thesis, it is the open question, actually, what comes after the cloud? So these things are emerging and evolving. The PCs have not gone away. Your iPhone has not gone away. The cloud does not go away. But what happens next that identifies this experience? Our thesis is that it moves to the network. And this is what caused me to become interested in working with Verizon. And I'm definitely an outsider. I don't know all the lingo that they have, but this was interesting to me. And so our innovation thesis follows the same trajectory. And we look at security at this level. We see kind of a similar pattern. So you move from a world that was filled with antivirus, right? Very simple hash lookups and matching. Remember those days of DAT databases and corrupted DAT databases that would shut down organizations, right? And it kind of moved to the next gen firewall and the IDS systems. I love IDS technology myself. I'm on the board of directors for Suricata. I love that kind of tech. The network security monitoring in general, right? Expanded and deterministic approaches, very much if this, then that, heuristics and signatures, those types of things. And then we move to the utility models, kind of more or less where we are today, although that's evolving, where it's about ubiquitous, fully on-demand, cloud-delivered, probabilistic approaches where we have machine learning and statistical computing and those types of things helping us make determinations, particularly with strength and robustness for the unknowns. But we see the next evolution as being about AI and access, like we just heard a great session on identity, right? So access and visibility and policy, detection and response, transparently built into connectivity and having that ubiquitously available. So this value and dynamic as living and existing above the network. And I'm going to peel that back a little bit. So when we think about 2025 and beyond, these are areas where we see growth. We see early adopters already moving, and we see our investments flowing along this axis. So let's go ahead. In the interest of time, we'll get to the next slide. The cloud is clearly on the front side of significant disruption. I think this is also non-controversial. Specifically, it's being expressed with edge compute, where you have carriers doing things like building multi-access edge compute. Many carriers have this type of offering, including Verizon, my new home, right? You have Amazon building Wavelength. It's a version of their Outpost, effectively, right? That's a bit more provincial and local. And then you have like cloud companies buying 5G and switching technology companies. I won't name anybody on that front, but if you've been following the news, you've seen some of this. And so we see this very basic migration and a highly composite landscape that has a traditional cloud, which is like the old-fashioned AWS, the old-fashioned version of the cloud, right? Where you have great centralized compute, but low, fairly high latency. 40 to 100 milliseconds is not unusual for application performance. Good enough for most human eyeballs, but not sufficient for like really large scale automation, which is where we need to go, right? Now you see a form of access and edge compute that is really pressing into the industry. Now we're looking at latency times of 5 to 10 milliseconds. So instead of workloads going from my location all the way out to Virginia or Northern California or wherever your cloud infrastructure is, it's actually in the cities. And for me, I live in Denver, Colorado, and that would be a location here in Denver, and not necessarily needing to transfer to the West Coast or to the East Coast for me. This is a big gain, right? It also fundamentally changes the kind of technology I build and the kind of technology I adopt and encourage to adopt. And now we see also a form of what's happening in this analytic spectrum on the embedded edge. And I'm going to flesh this out a little bit. The embedded edge is a form of edge computing. That's a concept that's been around for a long time. But what we're seeing is that we have systems that have intelligence that are pushed to the devices themselves, where you have very real, near real-time analytics, where latency is either immediate and like sub 1 millisecond, let's just call that 0 milliseconds plus, to like just a handful of milliseconds. And so this analytic landscape is following the migration of what happens with the cloud and what's coming next. But the important idea, what you're seeing here, is that connectivity and compute and devices' ability to communicate with each other are collapsing onto the same horizon. And as we look to the future, you're going to be able to find technologies that express that really well, make investments with regard to those things. But more importantly, it'll help you be able to develop a litmus test for what things are going to be durable, things that you can invest in now that you get to keep for a long time, and an architecture and a discipline and hiring and a skill set that is related to these types of things is really important for our teams. So you have kind of this traditional model of heavy processing in the cloud, high latency, right? You have low latency edge compute opportunities with pre-integrated networks and compute on top of them. This is a growing area. We're seeing a ton of movement in this direction. I think in some ways, what is old is new again, but with newer technology, it has become much more interesting to us. And then you have very lightweight processing on IoT and edge and those types of things. You have really small form factors. You have really good battery life, et cetera. And these, I think, are trends that we're going to see a whole lot more of. And we're starting to see startups and technologies being able to execute along this. And as a comment, so for instance, one of the things we're doing on the intrusion detection and intrusion prevention side, and I'm kind of wearing my Suricata hat, my Open Information Security Foundation hat a little bit, is that we're looking at the future of analytics with regard to threat detection. So that's two axes. One is the deterministic rules and signatures base. The other is the behavioral and statistical computing side of things, which looks for anomalies against baselines, right, of activity, et cetera. But we're also seeing analytic engines being built that are meant to dynamically transport between these locations. So you have an analytic engine that lives in the cloud, and then you have that same analytic engine living at the edge, and all those locations in between. And in a highly virtualized future where networks are virtualized and compute and storage and memory and all those things are virtualized, right, gives us an opportunity to make hyper-contextual technology that allows us to have on-demand analytics that could be in the far cloud or could be very real-time, embedded on-site or at the carrier edge, or et cetera. This is something that is happening today, and the people who are building solutions and technologies are arming up very heavily on this front. So I have one more slide for you guys, and I kind of want to walk you through a little bit of a case study. I can't tell you who this is. It is a very large energy provider where they have embraced a future rollout in basically like energy substations. We're talking like thousands of these things. This is a very, very large look into the future. It's oriented around 5G connectivity. Now, I promised Jana I would not pitch 5G, and I'm going to stick with that. Let's focus on the edge compute and the deployment model a little bit. 5G plus MEC, so multi-access edge compute, in a box for thousands of power substations with machine state integrity. So this is an approach to take a very, very large asset field that is incredibly hard to administer, but it looks kind of like the future of compute in general, where we have IoT, industrial IoT, you have operational technology networks and information technology networks, IT and OT, they're colliding. Who's winning that fight? That has been a struggle historically. The CISO is. You might say, and I apologize in advance to the OT people, but IT is kind of winning this, which is good because the entire organization's taking over this and it's going to be unified. And if you're an OT security professional, like is it domain specific for this environment, almost all OT attacks start as an IT attack, right? So this is a big deal. But as we look at this, you have all these substations where you have lots of devices that might have no compute or analytics on them. They can output some information and logs. You have some PCs like HMIs, human machine interface systems, and they're really in locations that you don't tend to staff. They're out there in the field. They're left alone for a long time. They're hard to get access to. And most importantly, you never want to touch them if at all possible. But we have to secure these things, right? And this is looking to the future. So what we did in this scenario, and this is a major deployment that is rolling out now. It's going to take years for all of this to deploy, but is using edge compute, this MEC idea, this multi-access edge compute that has security software and analytics loaded locally, very close, that has low latency, high bandwidth connections to those devices inside of those substations. It is backed up by the cloud. And it uses this technology that you can learn a bit more about. It uses blockchain and machine state integrity as an approach to looking for changes inside of systems. It's good for alerting on policy changes and violations, those types of things. But where it really shines is on changes that nobody saw coming and nobody expected. There's an update in firmware that had a side effect on a communication pattern that was not documented anywhere, but it's happening and it's a vulnerability. And apparently it's an angle to be exploited. This happens a lot. But looking into our future, you can see this kind of thing happening where we are looking at very near real-time systems that use highly virtualized compute and analytics that are fully on demand, some of it on site, on premise, a lot of it in the edge compute location that is ideally very local and in a metropolitan area close to where the analytic workload needs to happen. And then you have that all backed up by a traditional cloud where you can have large amounts of storage, the long analytic cycles, centralized dashboards, simplified user experience, et cetera. Now, as we look to the future, we're going to be hiring people to staff this line of technology. And as we look to the future of analytics and the future of compute, we're going to see seismic shifts in how people package and virtualize their products today. And I think that's really well expressed inside of Secure Access Service Edge. I think it's really well expressed in offerings around incident response and managed detection and response solutions. And I think it's really, most importantly, probably overwhelmingly well expressed inside of the kind of skill sets and workloads that we're going to be favoring and looking for as we hire and build our teams out into the future. So that is what I came to talk to you about. It's a conversation. Let's go ahead and move to some Q&A. I'd love to chat a little bit more.
Great. Thank you, Gene. Let's take some questions from the audience. Just remember you have the Q&A panel that you can enter your questions in. Don't be shocked if they don't appear. I have to approve them first and filter them to Gene. But our first question, since you were talking about the future, Gene, what sort of predictive analytics do you see coming out of the evolution of AI at the end point?
So the predictive analytics that we see are more along the lines of and anticipating like maintenance and upgrades and controls on that front. That's really near term. There are people already doing work on that front today, but the for a lot of unmanaged devices, you need in this kind of AI approach in order to anticipate when they need to be replaced or serviced, or a battery needs to be replaced or serviced, or connectivity has degraded, or something like that. The AI plays an important role at saying, looking at all this data point and predicting, it's like, you probably should consider replacing this within the next 4 months or something like that. With the proliferation of devices, we're reliant on that very much.
And, that kind of begs the next question, which is, you gave a great example for, power substations. What use cases do you anticipate in the financial services industry? I mean, I know there's smart buildings that certainly would fall into the IT OT space. Where else do you see this coming into play?
So I think this is really well expressed with regard to a lot of financial services companies and buildings and locations as turning into kind of a mix between consumer experiences and traditional transactional experiences. So you have, I remember I was talking to the CTO of a major processor, I won't name them, recently, and they are looking to invite people to come to their locations in order to do work. It's kind of like a work co-sharing location, but they want to have public Wi-Fi. They want to have easy access to their services, et cetera, and potentially access to experts, right? So when it comes to like edge analytics, we think security and network and connectivity need to go in a direction of making all that highly transparent and, if I can use the word, again, ubiquitous and maybe even promiscuous networks on that front. With a virtualized approach to this, we have access to things that we would not have dared to touch a few years ago because our systems can be fast at that. We don't have to anticipate every single attack to be correct. We just have to be faster than the attackers. And this low latency approach is a big deal. That's how we can win.
Yeah, no, that's an excellent point. And I love that vision of real estate as the thing you give away free to entice the customers. That's a really interesting angle I hadn't considered. Fascinating. Do you see the embedded edge, carrier edge, and traditional cloud all coexisting in the same environment? Kind of like a four stage architecture or something like that.
I do, absolutely. And I think the analytic workloads kind of require and play to this. So, for example, the embedded edge, you want to heavily emphasize deterministic approaches for analytic engines. Like that's, block lists, allow lists, signatures, heuristics, that kind of stuff. The traditional cloud doesn't go away because the machine learning and the time series analysis, and that seasonal decomposition, that kind of stuff, you don't need that at the edge. You need that happening in the cloud, and it pushes a model to the edge, right? And so the future is going to be all these things concurrently. That is not changing. The cloud does not go away. It is simply being disrupted in a way that's good for all of us.
That's a great way to simplify it. The greatest smarts and the greatest processing and data component is in the cloud, and the fastest processing is at the embedded edge and carrier edge in between. Okay, well, that does it for the questions we have. Thank you very, very much, Jean, for being with us today and sharing that vision of the future.